Okay, so just handed you the Ohm's Law Practice problems. There's the formula. It would be good to help you keep track is if you put that symbol there to help figure out the formula. Okay, now, some of you are already going. Before you get too far, I have a required way you have to report these things. You can't just give me the number. Anybody can write a number down. I want to see a little bit of work on it like you would have to do in a science or a math class. So if I take a look at number 1, what is the voltage if a resistance of 25 ohm produces a current of 250 amps? So, yep, 250 amps. For a second I thought it said milliamps. So 250 amps. I have a current of 25 ohm, and they are asking for the voltage. First step that I need to have is, what is the formula going to look like? Okay. So step 1 is voltage equals times R. That is step 1. I want the formula. Step 2. I want the numbers. If you feel like putting in the units, you can. Okay. Or just multiply the numbers together. Either way is fine. Okay, if this was a purely science class where we would have to follow stoichiometry, or we have to show our steps in the unit factoring, we have no idea how amps and ohms interact with their units to get to volts. We're not going to worry about that. Step 3, work the math. $250 times 25. Did I do it right? I have a really big tendency to do my math wrong when I'm in front of a group because I'm going too fast. Other people get the same number? Okay, so to run this circuit of 250 amps, which is a lot of amperage, that's a lot, at a very low resistance value, 25 ohms is not a lot. It's going to take 6,250 volts to make this thing happen. Wow. That's a lot. That's a lot. Now, can you do that? Sure you can. This to me right here could be a spark plug in reverse. Okay, if we're looking at an automotive spark plug, to get a spark plug to fire takes very little electricity to actually work. The amperage is very, very low because all the electricity has to do is basically bounce from one part of the spark plug to the next part of the spark plug. That doesn't take very much to do. However, we have an air gap between those 2 points. It's going to take a really big push to get that electricity to move. You with me so far? It's kind of like Jesse James jumping the gorge at where is it, Garrettson? I think it was Jesse James who did that. It was some character back in the Old West. At least that's the story. They're on the run from a bank heist and they jump a gorge. The gorge isn't very wide. I mean, it's a horse, for crying out loud. It's not going to be very, very wide. But to jump that gorge, the horse is going to have to be doing a lot more work or pushing than if it's just walking along the road. Okay? That's what a spark plug is doing. Little bit of amperage, a heck of a lot of resistance. It's going to take 7,000 plus volts to make that happen. And that's what an ignition coil does in a vehicle. It takes that 12 volt off the battery and steps it up to that really high voltage so a spark plug will actually work. Don't want to mess with that problem. You just buy a diesel and you never have to worry about it. Okay? So let's look at the second one. All right, number 2, what is the current produced by a voltage of 240 volts through a resistance of 0.2 ohms? All right, so we're looking for current, so that's going to tell me the formula is, cover up the letter I, is going to be volts divided by resistance. So there's my step 1. My step 2 is to plug in the math for it. Volts is 240 volts. Resistance of 0.2 ohm. Step 3 is my results. And it's going to be 12. But I don't know the decimal point. 1200. Match up? All right, number 3. What voltage is necessary to produce a current of 200 amps through a resistance of 100 ohm? What does my formula look like when I set it up?
Amps times, your amps times your ohms.
Well, number 3, what voltage is, yep. So, cover up, and if that didn't make sense, cover up the V. I'm going to put a little multiplication sign in the middle, amps times resistance. So, volts equals amps times resistance. $200,000, right? Is that right? I just moved the decimal place over 2.
I got 20,000.
Maybe I'm off. Yeah, 20,000. I'm off on my assumptions. Okay. Want to try the other ones on your own? I'll give you one more. Number 4. All right. what resistance would produce a current of 120 amps from a 6-volt battery? That's a lot of load for a 6-volt battery. But anyway, how is my formula going to look? What do I cover up? The V, the I, or the R? So R gets covered up, so that means volts divided by amps. So my formula is going to be R equals volts divided by amps. Next step is to plug in my numbers. And wait a minute. No, I'm just read it backwards. 6-volt battery, right? And the load is 120 amp. So 6 divided by 120. Run my calculator. A very low resistance of 0.05 ohm. All right, from there, you can finish the next ones.